Hello everyone, welcome to Anand's YouTube channel. This video is the continuation of detailed analysis solution series of class 12 mathematics exam, and this exam was conducted on March 9th, 2024. So in the previous three videos we have seen the solution of section A, B and C respectively. Okay, so if you have not seen those videos or you have not checked the answers of the corresponding question, you can uh, check the answers and solutions by clicking on the description links. Okay, in this video I am going to show you the solution of section D part. So in this section there are four long answer type questions, and each question will be of 5 marks. So overall the section D will comprise of 20 marks. So out of four questions, in three questions internal choices are given. Okay, you have to attempt all the four questions. So let's start with the question number 32. Question number 32 is taken from the first chapter of mathematics, that is relations and functions. So one question is related to relation and another question is related to function part. So let's read the first question. 32a. Here a function is defined from set A to set B by fx is equal to x minus 3 upon x minus 5, and we have to show that f is 1 1 and onto. And the second part is related to relation. A relation is given between a and b such that order pair a and b are related as a minus b plus root 2 is an irrational number, and we are asked to find whether this relation is reflexive, symmetric or transitive. So as you can see, you should know what is 1 1 and onto, and what is reflexive, symmetric or transitive. So if you don't know, let us first study the basic concepts involved in these two questions. So in relation to 32a, we should know what is the 1 1 and onto function. So here I have written the definition. A function is 1 1 if the image of distinct elements of x under small f are distinct. That is, f of x1 is equal to f of x2 implies that small x1 equal to small x2. So 1 1 function is also known as injective function, and onto or surjective function is a function when the, in simple word if I have to say, when the range of function f becomes equal to codomain of the function, that is y, then it is onto or surjective function. Or definition, why a function is said to be onto if every element of y is the image of some element of x under f. Okay, so that means codomain will not contain any y for which there will not be any x in the domain part. So these are the basic things you should know before you start solving the 32a part. Let's start with the proving. So to check whether a function is 1 1 or onto, we should check whether fx1 is equal to fx2 or not. So if we put fx1 and fx2, sorry, if you put x1 in fx and x2 in fx, you will get x1 minus 3 upon x1 minus 5 equal to x2 minus 3 upon x2 minus 5. If you cross multiply these two sides, okay, and simplify the equation, you can see after 4 steps we are getting minus 2x1 equal to minus 2x2. This implies that x1 equal to x2. So if x1 equal to x2 is coming, then therefore f is 1 1. Let's check whether this function f is onto or not. So to check for onto function, we have to check whether y can be whether x can be expressed in terms of y or not. So replacing fx by y, we got y is equal to x minus 3 upon x minus 5. Cross multiply it, and rearrange the equation, and after few steps you will get x is equal to 5y minus 3 upon y minus 1. So looking at this equation, we can say this denominator is defined only when it is not 0, or we can say x is defined where y minus 1 should not be equal to 0. So y can contain all the real numbers except 1, because at 1, 1 minus 1 is equal to 0. So in the function domain, codomain is also given, that b is also given r minus 1, and here range is also coming as r minus 1. That means range is equal to codomain, so this function is also onto. So we were asked to find whether f is 1 1 or onto. So we can simply say f is both 1 1 and onto, and in that case we can also say f is bijective function, because bijective is both 1 1 and onto. Now to solve the second part, it is relation part, we should know what is reflexive, symmetric, and transitive. And before moving to that part, we can compare whether we should do 32a or 32b. So I think 32a is uh, less lengthy and less difficult also. So it is advisable to solve 32a part, and whoever chose that part in the exam will get same marks. Okay, so I think out of 32a and 32b, 32a is smart choice. But anyhow, we will solve both the part. Now relation is called reflexive when this order pair a comma a belongs to relation r for every a small a belonging to capital A. A relation is called symmetric when a1 comma a2 belongs to r implies that a2 comma a1 also belongs to r for every a1 comma a2 belongs to capital A. A relation is called transitive if a1 comma a2 belongs to r and a2 comma a3 belongs to r implies that a1 comma a3 also belongs to r for all a1 a2 a3 belongs to capital A. So here we can say whether S is reflexive or not by putting simply A in place of B. So when we put A in place of B in the equation A minus B plus root 2, we will get root 2, and root 2 is, as we know, is an irrational number. That means S is reflexive because A comma A belongs to relation S. Now in the check of symmetry, we will take an example. Let us take A minus B equal to root 2, then B minus A will become minus root 2, and we are getting a minus b plus root 2 as 2 root 2, which is irrational, but b minus a plus root 2 is 0, which is not uh, an irrational number. It means a comma b belongs to relation S, but b comma a does not belong to relation S. That means S is not symmetric. And for transitivity we can take three numbers a b c, and uh, to check whether if a comma b belongs to S, b comma c belongs to S, and then a comma c should also belong to S, we will first write relation between a and b as a minus b plus root 2 and b and c as b minus c plus root 2. Add these two equations, you will get a minus c plus root 2. Now it is not necessary that two rational numbers when are added will give an irrational number. For example, minus root 2 is an irrational number, and 2 plus root 2 is also irrational number, but their addition is giving us 0, which is rational number. That means it is not necessary that if a comma b belongs to S and b comma c belongs to S, then a comma c will also belongs to S. So in other word we can say S is not transitive. So simply S is in this case only reflexive. So if you have solved NCRT exemplar, then you know this question was taken from uh, this that book, and that too in the MCQ part. So it is not necessary that if you study the main textbook only, that you will get all the marks. You should read NCRT exemplar and other reference book also. Now move to question number 32, 33, sorry. 33 again contain two internal choices, and this question is taken from the topic of three-dimensional geometry. Okay, so the first question is asking us to find the distance between two lines, and the problem is that the distance between those two lines cannot be found directly by using the formula here, because one line equation is given but the another line equation is not given. A condition is given for the another line. Uh, and the 33b part is asking us to find the first. There are two things to find in the question number 33b. First, the value of k for which the given two lines should be perpendicular, and the second part is asking us to find the vector equation of a line perpendicular to these two lines and passing through a point 3 minus 4 comma 7. So I think again I've already solved this both questions, and if we uh, have to choose smartly which part we should do, so I think 33a again is the smart choice to do in the exam, because it is less time taking and easier to solve, although 33b is also not difficult, but it will take some time. But anyhow, we will solve both the question. But in the exam, if questions like this come, you should always solve the questions which take less time and less thinking. So for that, you have to practice thorough enough so that you can decide in the exam. You cannot decide randomly. So let's solve first part first. So if the equation of a line passing through the point x1, y1, z1 and lmn are the direction cosine, then the equation of the line is given as x minus x1 upon m, y minus y1 upon m, and z minus z1 upon n. And another formula that we are going to need is that if equation of two lines are given in vector form, and the distance between those two parallel lines is uh, modulus of b vector cross a2 minus a1 divided by modulus of b vector. Now here we have to understand, when the equation of a line is given in vector form, then how should we represent it? Let us say example, by taking this diagram. Here the line is this, and this equation we are asked to find. Okay, so a general point should be given on this line whose equation is a vector, and this line is parallel to another line which is b vector. So we can say that r vector is equal to a vector plus lambda b vector. So in the equation of r vector is equal to a vector plus lambda b vector, a vector is a general point on the same line, but b vector is not on that line. In fact, b vector is the line to which r vector is parallel. Okay, so using these two concepts, we will find the distance between the two lines. Here equation is not given in the standard form, so we will convert it into first Cartesian form. So in the Cartesian form, it will be x minus 0 by 2 is equal to y minus 3 by 2 is equal to z minus 1 upon 1. Now to convert this into scalar form, we can see that here general point is 0, 3, 1. So 0 I cap plus 3j cap plus k cap plus, and it is direction cosine is 2, 2, 1. So lambda 2 I cap plus 2j cap plus k cap. And another line is parallel to this line, that is L1. So its direction cosine will also be 2, 2, 1. So instead of lambda, only you have to replace it by mu, and after lambda it will be same thing. And the line is passing through 405, 40 minus 5. So its complete equation will be this: r vector is equal to 4 I cap plus 0 j cap minus 5 k cap plus mu into 2 I cap plus 2 j cap plus k cap. Now just apply the formula Here a1 vector I have written here, a2 here and b vector. Now do the a2 minus a1 thing, you will write that here, and b vector part is here, and in the first row you will write I cap, j cap, k cap, and in the denominator you have to write the modulus of b vector. So modulus we will calculate 2 square plus 2 square plus 1 square, and all other calculation I have already done. So numerator part is coming as minus 9 I cap plus 16 j cap minus 14 k cap, and take the modulus and solve it, you will get the answer as uh, under root 533 upon 3 units. Okay, so this is the answer of 33a. Now to solve 33b, we again need some basic concept. So if two lines are given with direction cosine L1 M1 N1 and L2 M2 N2, then the lines will be perpendicular when L1 L2 plus M1 M2 plus N1 N2 is equal to 0, and line will be parallel when their corresponding ratios are proportional. And another thing we also need to solve the part B is that when we are asked to find a vector which is perpendicular to given two vectors, then we will apply the formula b3 vector is equal to b1 cos b2 vector. Here b3 vector is perpendicular to b1 vector and b2 vector both. Okay, so applying these two formula, we will now calculate 33b part. In this I have already told you r vector is equal to a vector plus lambda b vector. Now here the equation is again given in the form of k, and they are already written in form of a standard. So just multiply their corresponding L1, L2, M1, M2 and N1, N2 value. We will get equation, because we are asking to find value of k when L1 is perpendicular to L2, and we applied the formula and we get the value of k as minus 2. Now when k becomes minus 2, that means line L1 direction cosine will become minus 3, minus 6 and plus 2. And when k becomes minus 2, line L2 direction cosine will become minus 6, 1, minus 7. Okay. Now this L1 direction cosine give us the value of b1 vector and b2 vector, because if L1 equation is has to be written in vector form, it will be written like r vector is equal to a1 vector plus lambda b1 vector, and for L2 we can write r vector is equal to a2 vector plus mu b2 vector. Now in the question we are asked to find a third line which is perpendicular to both L1 and L2. So how we will find? We will first take the cross product of b1 and b2 and then equate it to b3. So that's what I have already done using this figure. So calculate the value of b3 like this. And if you solve it, you will get b3 as 26 I cap minus 33 j cap minus 26 k cap. And this b line L3 is passing through 3 minus 4 7. So its equation will be 3 I cap minus 4 j cap plus 7 k cap. So answer will be r vector is equal to 3 I cap minus 4 j cap plus 7 k cap plus lambda into 26 I cap minus 33 j cap minus 27 k cap. So this is the required answer. Now let's move to question number 34. Question number 34 is asked from the chapter of determinants. Again, a very basic type of question. We are asked to find the solution of the given system of equation, and we are not just simply asked to find by using this equation. We have to first calculate a given product of two matrices, and then we are asked to find this value of xyz. We are not asked to find using it conventional method by first calculating a inverse, then multiplying it with b, and then finding x. So let us see how this product is going to be useful for us. So if you see carefully, this first matrix is A itself. Using this equation, you can write 1, 2, minus 3, and so on, 3, 2, minus 2, and 2, minus 1, 1. So assume this as first A, and this second matrix is, and we don't know yet what kind of equation it will get. So let us assume it as P. So to solve this question, some basic concepts you should know, that how we should multiply two matrices. So here I've already written. If you don't know, you should read this and try to first understand this, then only you can solve this question. So first I have given the theory for multiplication of two matrices. Okay, and in second part I have given the definition of inverse. Inverse formula is 1 by mod A adjoint of A. In third I have given what is adjoint of a matrix. And then for adjoint of a matrix, you should know what is minors and cofactor. Then I have given definition of minors and cofactor. And then I have given the definition of transpose of a matrix, because in adjoint, after calculating the cofactor, you have to take the transpose of that matrix. It's simply interchanging the rows and column, we will get the transpose. And at last, you should need equation should be written in this form, that all the constant will be on RHS and all the variables on LHS. Then will form a matrix of Ax equal to B, and rearranging the equation you will get x is equal to A inverse B. So this A inverse we don't have to calculate, because I think that product will give us A inverse only. So let us solve that question. So if we multiply these two matrices A and P, we are seeing that we are not getting directly I, but we are getting 7I. That means we can write A into 1 by 7 of P is equal to I. So this clearly states that if A is multiplied by something, when we are getting identity matrix, that means that something is nothing but inverse of A. So here it is clear that A inverse is equal to 0, 1 by 7, 2 by 7, minus 1, 1, 1, minus 1, and 4 by 7, and minus 4 by 7. So A inverse become this, and multiply it with the B. And B here we can see with the help of equation, that is 632. And if you multiply this, you have to multiply first row of this and first column of this, and first second row first column, third row first column, and solve it. You will get value of x as 1, y as minus 5, and z as minus 5. You can also check uh, by putting the value of x, y, z in the all the three equation. Although I think this equation is this answer is correct. Now let us move to the last question of section D, that is question number 35. Again, there are two options given in this question, and this question is taken from the chapter of applications of integral. Applications of integral. So here again some basic concepts are needed to solve this question. We're simply asked to draw the graph of pi is equal to x mod x, and then find the area bounded by this curve between x-axis, ordinate x equal to minus 2 and equal to 2. And the second part, ellipse is given. We are asked to find the area bounded by the ellipse between the x-axis lines x equal to minus 2 and x equal to 2. Basic concepts is needed. You should know what is modulus function. So modulus function, here I have drawn the graph, I have written definitions. Should read it. In short, I can say if fx is equal to mod x, then fx takes two values. First is positive x when x is greater than or equal to 0, and second is minus x when is less than 0. Then you should know what are the standard equations of an ellipse. So equation of ellipse is simplest when the center is at origin and its two focus are at either on x-axis or y-axis. And there are two kinds of ellipse. One is horizontal ellipse, and another one is vertical ellipse. So how we can say one is horizontal and one is vertical? So if the major axis is on the x-axis, then it is horizontal, and if the major axis is along y-axis, it is. So we have to check the number below x to check whether it is major or minor. So if A is greater than B and A lies below X, then it is horizontal ellipse, and if A lies below Y, it is vertical ellipse. And all the corresponding coordinates you can calculate at the corner point by using this diagram. Okay. And the third thing you need in the theory is area under simple curves. So when the equation of function is given in the form of y is equal to fx, we have to calculate the area bounded by this curve x axis and the lines x equal to a and x equal to b. So there is a formula. We have to calculate the integral y dx with limit a to b, or we can calculate the integral fx dx between a to b. Now apply these concepts to 35a and 35b, you will get the required answer. So your first graph is of y is equal to x mod x. Now these take two values, x plus x square and minus x square. And when x takes minus x, you have to keep in mind when the quadratic equation is given and with positive x square coefficient, then graph will be above x axis, and when the x square coefficient is negative, graph will be below x axis. So one part will be above the x axis and one part will be below the axis, although you will not get different answer if you have drawn both the graph on the above axis, but your marks will be deducted because here sketch is asked to drawn. So keep in mind that sketch should be correct. Now apply the formula of y dx, and using vertical strip we can calculate the area, and we can see both the areas are symmetrical, so will just apply 2 times of that area, 2 times of one part, and integrating x square from 0 to 2, x cube by 3 will take the limit of 0 and 2, and by putting the values we will get the answer as 16 by 3 square unit. So in my opinion 35a is easier to solve and very less time taking, but in sketch I think most of the students will do mistakes. So keep in mind it is easier and less time taking, but it is also uh, critical to think that you should draw correct graph. Now come to the 35b part, it will be of ellipse. So equation is not given in standard form, we will calculate it in standard form and converted it, and we got x square by 5 square plus y square by 3 square. So we can easily see the x square coefficient is greater than y square coefficient, so it is the case of horizontal ellipse. And by drawing the graph of horizontal ellipse, we can see all the corresponding corner points and ordinates of x equal to 2 and minus 2, and from the equation of ellipse we isolated the y value as 3 by 5 under root 25 minus s square. Now we can see very smartly that if we calculate the area of one part, then all other three parts are symmetrical to it. So it is better to calculate the area of one part and multiply it by 4 to get the required answer. So I've done that same thing 4 times of uh, integral 0 to 2 y dx. Now put the value of y and you will get the answer. Now here the integration part is little bit difficult because you have should know this formula. Integral of under root a square minus x square contains two things in its integration. First part is x by 2 under root x square minus a square minus x square plus a square by 2 sine inverse x by a plus constant of integration. Since it is different integration, you will not get c. Now when you put the values of 0 and 2 and solve and simplify the equation, you will get the area as 12 by 5 in bracket under root 21 plus 25 by 2 sine inverse 2 by 5 square roots. Okay, so this completes the section D of the question paper. In the next video, we will see the solution of section E part. Okay. Thank you for watching this video and have a nice day.